Welcome back to the Deep Dive. Today, we are opening up a topic that I think is going to hit a little too close to home for a lot of you.
Agrees.
We've all been there, whether you're running a logistics network, managing a smart building, or heck, just trying to get a straight answer out of your own fitness tracker.
Right.
It's that feeling of being absolutely drowned in data, but just starving for a single useful insight. You have the numbers, you have the graphs, but you don't actually have the answer.
It is the defining frustration of the digital age, really.
Yeah.
In the industry, we call it the data action paradox. And honestly, it's the reason why so many of these big digital transformation projects just end up as expensive failures.
The data action paradox, it sounds so academic, but the reality is just messy. We see companies spending millions to wire up everything. I mean, sensors on every pump, every valve, every delivery truck.
Oh, yeah.
They build these huge command centers that look like something off the bridge of the Starship Enterprise. But, and this is the kicker, critical equipment still fails without warning.
Exactly. Or worse.
Or worse, the team is so flooded with low-level alerts that they just miss the one red light that actually matters.
That's it. We've become very good at the IoT part, the whole Internet of Things. We can connect basically anything to the Internet.
Mm-hmm.
But we're surprisingly bad at the action part.
So that's the paradox.
That's the paradox. Having more data often leads to slower decisions because you have to wade through all this noise to find the actual signal. You're just being reactive.
It's kind of the dirty secret of the industry, isn't it? We bought the haystack, but we still can't find the needle.
Well said.
So today we're breaking down a framework that claims to solve this. We're doing a deep dive into the Favoriot Insight Framework, or FIF. Now, looking at the documentation, this isn't just a software pitch. It reads more like a methodology, a 6-layer map.
It is a map, and that's crucial. Most organizations look at IoT as a technology stack, sensors, cloud, app. The Favoriot framework argues it's actually a logic stack.
The logic stack.
An end-to-end approach that starts with intent and ends with automated action. And if you miss a layer, the whole thing just collapses.
Okay, let's unpack this. The framework has 6 layers labeled 0 through 5. And I have to say, I was surprised to see it start at layer 0. It feels a bit like a software engineer's joke.
Agrees.
But looking at what it is, it seems like the step everyone skips.
It is the step everyone skips. And it's the primary reason for that alert fatigue we were just talking about. Layer 0 is intent and context definition.
Which, sounds a bit like corporate speak for having a meeting. So play devil's advocate for me here. Why can't we just install the sensors and let the data tell us what's wrong? Why do we need this whole philosophy phase?
Because data without context is just noise. It's meaningless. If you install a vibration sensor on a motor and just turn it on, what does that data even mean?
Right.
Is a vibration level of 5 bad? Or is that totally normal for a machine running at full capacity?
Yeah.
If you haven't defined normal in layer 0, your system is going to flag everything as an anomaly.
And then you end up with a dashboard that's just lit up like a Christmas tree, and the maintenance team just mutes all the notifications.
Precisely. Layer 0 is where you define the business problem. Are we trying to prevent a breakdown, or are we trying to optimize energy usage? Those are two very different goals. They need different data. You also have to define your risk appetite.
Your risk appetite.
Yes. How much variance are you willing to accept? In a nuclear power plant, your risk appetite is basically 0. A 1% fluctuation is a crisis.
Sure.
But in a city sprinkler system, a 1% fluctuation is, well, it's Tuesday. If you don't bake those rules into the foundation before you buy the tech, you are building a system that is literally designed to annoy you.
That makes so much sense. It's like planning a road trip. If you don't decide where you're going and what route to take, just having a car with a full tank of gas doesn't help you at all.
It doesn't. You're just driving in circles efficiently. That's a great analogy.
So layer 0 is the map.
Layer 0 is the map. And once you have that map, then and only then do you move to layer 1, the data foundation.
Okay, this seems more like the nuts and bolts layer. The documentation talks about telemetry, connectivity, security.
It's the plumbing, but you can't gloss over it. This is where the physical world gets translated into digital signals. And the key phrase here is one you've heard a million times. Garbage in, garbage out.
It's a cliche because it's true.
And it is especially true here. If layer 1 is compromised, let's say your sensors are uncalibrated, or your network is dropping packets, or the time stamping is off by a few seconds.
Then everything on top is worthless.
It's worse than worthless. It's misleading. You might have a fancy predictive AI telling you a machine is healthy, but only because the sensor that would report the failure has a dead battery.
So layer 1 isn't just about connecting things. It's really about establishing trust. If I can't trust the raw telemetry, I certainly can't trust an automated decision later on.
Exactly. Trust starts at the source. This layer handles all that data ingestion and storage, making sure it's managed securely. Without a rock-solid layer 1, the rest is just science fiction.
Okay, so we have our intent from layer 0 and our trusted data from layer 1. Now we get to the stuff people actually see. Layer 2. Descriptive insights. This feels like where most companies live and buy, the dashboard.
Yes, the descriptive layer, this is powered by what they call Favoriot analytics. It answers the fundamental question, what is happening right now? And maybe what happened yesterday.
The pretty charts, the pie graphs showing uptime.
It creates shared visibility, which is valuable, don't get me wrong. It replaces the old clipboard. Instead of a guy walking around writing down pressure readings, you have a screen everyone can see. It's a single source of truth.
But, and I feel a big but coming, is a dashboard actually insight?
That's a critical distinction. Layer 2 is a mirror. It reflects reality, but it doesn't explain it. If you see a spike in energy consumption on that dashboard, you know that it happened. You don't know why it happened.
And you don't know if it's going to happen again.
Not at all.
And that brings us right back to the data action paradox. If I'm just sitting there staring at a screen, watching lines go up and down, I'm still the one doing all the mental work. The computer isn't helping me think, it's just giving me homework.
Correct. Layer 2 relies on human vigilance. And humans, well, we're terrible at vigilance. We get bored, we get tired, we miss things. To move from data to wisdom, you have to climb to layer 3.
Layer 3. Diagnostic insights.
Yes. This is where it gets interesting.
The shift from what to why.
This is where we start using analytics to actually understand relationships. In layer 2, you see a temperature spike. In layer 3, the system looks at the context, remember that stuff from layer 0, and it correlates that spike with other variables.
Walk us through an example. How does the system figure out the why?
Okay, let's take a large industrial pump. Layer 2 shows the vibration is high. Okay, bad news, but why?
Right.
Layer 3 analyzes the correlations. It notices that when the vibration goes up, the flow rate drops, but the power consumption stays steady. It compares this pattern to historical data and known failure modes.
So it's acting like a detective. It's saying, okay, high vibration plus low flow usually means a blockage, not a bearing failure.
Exactly. If it were a bearing failure, the temperature might be spiking too. By cross-referencing all these variables, layer 3 can diagnose the probable root cause. It tells the operator, high vibration, likely due to an inlet blockage.
Wow, that's a massive leap. Instead of me just sending a technician to go check the pump, which could take hours of troubleshooting, the system is telling them what tools to bring.
It massively reduces the mean time to repair. You're not guessing anymore, you're verifying, but it is still looking backward. It's explaining a problem that's already happening.
Right, the pump is already vibrating, the blockage is already there. We're still reactive, we're just reacting smarter.
And to truly break the paradox, we need to get ahead of time. We need foresight. And that is layer 4. Predictive insights.
Now we're getting into the crystal ball stuff. This is where the AI buzzwords usually show up.
They do, but let's just strip away the hype. Layer 4 is all about probability and trends. It uses all that historical data from layer 1 and the relationships it learned in layer 3 to forecast what's going to happen. It answers, what will happen?
So instead of the pump is blocked, it's saying the pump is going to block.
Or, even better, the motor winding insulation is degrading. Based on current usage patterns, there is an 85% probability of failure within the next 96 hours.
That changes the entire operational model. You're not fighting fires anymore. You're actually preventing them.
It allows for just-in-time maintenance. You don't fix it too early, which wastes money, or too late, which causes downtime. You fix it exactly when it's needed.
But there's a trap here, isn't there? I've seen these predictive systems where the prediction just becomes another alarm. Warning, 80% chance of failure. If I don't know what to do with that information, it's just anxiety.
High-tech anxiety is a great way to put it. And you're absolutely right. Knowing the future is useless if you don't have a plan to change it. That's why the framework doesn't stop there. It culminates in layer 5.
The top of the pyramid.
Layer 5. Prescriptive insights.
What should be done?
This is the so what layer. This closes the loop. It combines the prediction from layer 4 with all those business rules and logic we defined way back in layer 0.
So we're circling all the way back to intent.
Always. Layer 5 takes that prediction, failure in 96 hours, and it checks the rules. Is this a critical asset? Yes. Do we have a spare part in inventory? Yes. Is the maintenance team available on Tuesday? Yes.
And then what? It sends an email.
Ideally, it goes way beyond a simple notification. In a really mature Layer 5 system, it automatically generates a work order in the system. It schedules the downtime. It reserves the spare part. It might even adjust the machine's own operating parameters, like slow it down to reduce strain so it survives until the maintenance window.
That is the action in the data action paradox. It's not asking for permission, it's presenting a fully formed solution.
Exactly. It shifts the human role from monitor to approver. Instead of staring at the dashboard, the facility manager gets a ping on their phone. Pump 3 requires bearing replacement. Slot scheduled for Tuesday at 8 a.m. Approve.
They just click yes, and it's done.
It's done.
That sounds incredible for a factory, but the source material says this isn't just for manufacturing. It talks about smart cities, utilities, even museums. A museum seems like a really strange edge case.
It's actually a perfect example of why Layer 0 is so important. Think about a museum. You're not managing a production line. You're managing an environment. Your product is preservation.
Right, you have ancient tapestries, delicate oil paintings. They're very sensitive.
So Layer 0 defines those strict parameters. Humidity must be between 45 and 50%. Light exposure must not exceed X lumens per day.
Got it.
Layer 1 collects the data from sensors in the galleries. Now, Layer 4, the predictive part, notices a storm front is moving in, which historically spikes the humidity in the West Wing.
And Layer 5?
Layer 5 doesn't wait for the humidity to spike and ruin a priceless painting. It talks to the building's HVAC system now. It pre-adjusts the climate control to counteract the incoming weather. It maybe closes the automated blinds.
So the curator never even gets an alarm. The environment just stays stable.
That's it. The best outcome of the Favoriot Insight Framework is silence. A boring dashboard. The system handles all the variants so the humans don't have to panic.
That's a powerful idea. The goal isn't more data. The goal is a boring day at work.
In operations, boring is the highest compliment you can get.
So let's wrap this up. We've climbed all 6 layers. We started with intent, built a data foundation, visualized it, diagnosed it, predicted the future, and then finally took action.
It really is a journey from noise to signal. And it transforms the whole organization. You stop rewarding people for being heroes who have to rush in and fix broken things at 2 a.m.
Right.
You start rewarding the system for making sure things never break in the first place.
That culture shift has to be harder than the software installation.
Always. Trusting an algorithm to make decisions, really trusting Layer 5, that takes time. You have to prove that Layers 3 and 4 work first. But once that trust is there, the efficiency gains are just exponential.
So here's my challenge to everyone listening. Tomorrow morning, when you open up your laptop and you look at whatever dashboard runs your world, whether it's sales figures, server uptime, your fleet management map, ask yourself one question.
What layer am I looking at?
Exactly. Are you just looking at a mirror of what happened yesterday? Or is that screen telling you exactly what you need to do today to win tomorrow? And if you're just staring at a mirror, you might need to go back and have a very serious conversation about Layer 0.
And maybe turn off a few of those useless notifications while you're at it.
Amen to that. Thanks for joining us on this deep dive into the Favoriot Insight Framework. We'll see you next time.
Goodbye.